All right, let's dive right into it. Today, we're unpacking one of the most massive technological shifts we've literally ever seen. We're going from the basics of traditional machine learning all the way to mastering prompt engineering. Welcome to The Explainer. Let's look at how algorithms went from just crunching numbers to, well, actually creating things from scratch.
So before we get completely bogged down in the technical mechanics, I want you to consider something. What actually makes AI creative? I mean, for decades, AI was basically just a super advanced filing clerk, right? It was great at sorting and predicting based on past data. But how did it cross that threshold? How on earth does a machine learn to compose a sonnet or design a skyscraper? That huge leap from simple calculation to actual creation is exactly what we're tackling today.
Okay, here's our roadmap for today's explainer. We're hitting 1. The generative AI revolution. 2. Discriminative versus generative AI. 3. Inside large language models. 4. The prompt engineering lifecycle. And finally, 5. Advanced prompting techniques.
Let's kick things off with Section 1, the generative AI revolution.
The crucial difference in this completely new era is that generative AI doesn't just understand existing data, it actually innovates. Think about it like this. Older, traditional models might read a bunch of Shakespeare plays just to count how many times you used certain words. Pretty boring, right? But a generative model learns those underlying patterns so deeply that it can actually write a brand new, totally original play in his exact style.
Moving right along to Section 2, discriminative versus generative AI.
To put it simply, think of discriminative AI as a highly efficient data analyst. Its whole job is to draw boundary lines, like figuring out what makes an email spam versus not spam. Generative AI, on the other hand, is way more like an artist. It acts as a creator. It doesn't just look for those boundary lines, it maps out the entire pattern of the data so it can generate something completely new that feels incredibly authentic.
So if you're working at a business and trying to predict future sales or segment out your customers, you're definitely going to want traditional discriminative AI to classify that data. But if you're looking to automate your copywriting, synthesize realistic audio, or generate custom artwork for a campaign, well then you are operating entirely in the realm of generative AI.
All right, Section 3, inside large language models.
These deep learning models are primarily built on what we call transformer networks. And honestly, they're fundamentally designed to do just one simple thing, predict the next word in a sequence. That's it. But by processing data in parallel and keeping track of incredible long-range context, they represent a total game changer from older AI architectures. Literally just by predicting the next token over and over again, these models can churn out full essays, write flawless Python code, or hold totally fluid conversations with you.
You know, you've almost certainly used some of these already. GPT-4, Gemini, Llama, Palm, they're everywhere. And they really showcase the unbelievable power of training on just massive, unlabeled datasets. It used to be that AI needed perfectly matched pairs of, say, English and French sentences to learn how to translate. But these modern LLMs, they just consume an absolute ocean of unstructured internet text and naturally absorb the complex structures of human language.
Now, check out the architectural choices that actually drive this stuff. On the left side there, you have encoder-only setups, like BERT. These look at a whole sentence all at once to grasp the context, which is absolutely perfect for analyzing text. But for actually creating content, we rely heavily on the decoder-only design you see on the right. Models like GPT predict the next word based exclusively on the previous words, which, when you think about it, perfectly mimics how human dialogue naturally unfolds.
Next up is Section 4, the prompt engineering lifecycle.
Okay, so we've got our incredibly powerful AI engine, right? But how do we actually steer the thing? Well, that is exactly where prompt engineering comes into play, because retraining an LLM from scratch takes massive computational power and millions of dollars. Prompting lets you completely bypass all of that. You are essentially programming the model on the fly using just plain English. You're taking its vast general knowledge and tailoring it to your highly specific task, all without writing a single line of traditional code.
And following this life cycle takes prompting from being a total guessing game and turns it into an actual scientific procedure. You can't just type a vague question and hope for the best. First, you have to design clear, precise instructions. Next, you test it out, and often you explicitly tell the model to think step by step. Finally, you analyze that intermediate output and refine your prompt's length, tone, or structure until the AI is behaving exactly how you want it to.
And that brings us to our final stop, Section 5, Advanced Prompting Techniques.
Look, building rich context is basically the whole ballgame. You have to tell the LLM exactly what matters. If you want code, don't just say write a script. Demand object-oriented programming in Python with your specific naming conventions. If you're having it write an article, clearly define the tone as, say, professional yet approachable, and flag exactly which keywords it needs to avoid. Bottom line, the more constraints you give it, the less the model has to guess what you actually want.
Now, zero-shot prompting, which is asking a question with literally zero prior examples, is fine for simple everyday queries. But the second you need complex formatting, you have to move to few-shot prompting. Since these language models are phenomenal pattern matchers, feeding them just 2 or 3 examples of the exact output you want acts as a powerful anchor. The AI instantly latches onto that pattern and replicates your logic flawlessly.
Oh, and here is a super fascinating technique. Sometimes standard English is just a bit too ambiguous. If you find a model is misinterpreting your complex instructions, you can actually define a custom shorthand or pseudocode right inside the prompt. Once the LLM learns the semantics of this alternative language you've created, you can communicate with it with incredible density and absolutely zero ambiguity. It's a real game changer.
Take a look at this prompt. From now on, I would like you to ask me questions to deploy a Python application to AWS. When you have enough information, create a script to automate the deployment. I love this because it completely flips the script. Instead of you sweating over trying to figure out every single detail the AI might need, you just instruct the AI to interview you. It transforms the LLM from a basic answering machine into a deeply collaborative, problem-solving partner.
The era of discriminative AI taught us how to efficiently analyze the past, but generative AI truly empowers us to build the future. But remember, the real power doesn't just sit there in the models themselves. It entirely depends on how effectively you communicate with them. So start experimenting with your prompts, build out better context, and just watch your daily workflow transform. I want to leave you with this. How will you turn AI from a passive tool into a collaborative partner in your own daily workflow?